Hello everyone, thanks for joining us for another episode of Crops TV. My name is Ryan Bergman. I work in the Department of Agricultural and Biosystems Engineering here at Iowa State University. Today I'm going to talk with you about some targeted spraying technologies. We're going to review where these technologies came from in the past, where they're at presently, and where they're going in the future. We're going to start with some introductions of some basic terminologies around these technologies that are important to know in order to competently talk about these technologies with others. Then we'll talk about, just like we said, where they came from, where we're at today, and where we're going. We're going to talk about some key requirements and different drivers and benefits for wanting to employ these technologies in our operations. We'll review the impacts that they could potentially have to our crop production practices here in the Midwest and across the world. And finally, we're going to talk through how to set different types of technologies up and evaluate them for your operations, for your customers, and for the folks that you commonly work with on a daily basis. So to start with, I think it's important to understand and review, why do we need targeted spraying? Why are so many folks interested in this type of technology and wanting to advance towards this in the application industry? So first off, we're constantly dealing with pest resistance. Here in Iowa, most recently we're dealing with a wide amount of water hemp resistance that continues to be problematic for many of our growers and agronomists and suppliers across the state. Secondly, pesticide costs continue to increase. Most of these products aren't becoming any cheaper. We continue to need to put more products in the tank to get effective control of the target pests that we're after, and so that costs us a significant amount of money. So the opportunity to potentially reduce costs and increase our bottom line is always appealing to a lot of folks. Next is environmental sustainability. By employing technologies like this, we can start to reduce our negative environmental footprint, and this is starting to be demanded more and more by our customers. We know folks are wanting to see more sustainable products, and this is just one piece of that to try to get towards a more sustainable future in agriculture. Finally, and potentially most importantly, is just offering us greater flexibility and more options with our herbicide applications in agriculture row crop production. By employing technologies like this, that might give us the opportunity to change our herbicide plans, change up our timing practices of when we want to spray, and just gives us different options and flexibility that we maybe didn't have in our operations before. So there's different types of systems out there. What we're going to have tomorrow is going to be very different than what we might have available today. A couple of basic terms that are often used in this industry, and if you start reading up on different targeted spraying technologies, you'll often hear these terms used. The first is green on brown capabilities, or green on brown spraying, and this is referring to spraying anything green in a typical fallow ground environment. So essentially on a bare field, we're going to go out and spray anything green that we view as living out there. This technology isn't as applicable here in the Midwest to row crop production. We don't typically manage a lot of fallow ground here, and so we probably won't see wide-scale adoption of these systems. However, in other parts of the country and other parts of the world, they do often manage a large amount of fallow ground year to year, and so the ability to maintain weeds and keep weeds off that ground while still reducing herbicide use is a huge driver for this technology. Finally, and where I think we're going to continue to see a lot of growth, is in the green on green technology. And this refers to identifying and spraying a targeted weed, where there's other green stuff around. Typically that other green stuff would be the crop that we're trying to grow. And so being able to distinguish a weed or a target pest from the crop that we're trying to grow, and then prescriptively spray just that weed, is really the future of this technology. And this is likely where we start to see the most impact to our Midwest and our Iowa crop production practices, is with green on green technologies. So where we're coming from in the past, the idea of just targeted spraying or just spraying the pests that we're after isn't necessarily new. For various reasons, we've done this in the past, and this is truly just an older version of what we're after today, and a more maybe a less efficient version of what we're after today. So we had this type of technology where we might manually go out and dose weeds or pull weeds, and that idea is still very similar to what we have today, where we're targeting just the weed, trying to minimize over application on the crop, and really get to the weeds in a timely manner. This technology's really been around for quite a while. Most people think that this has really been something that's come about in the last 5 years, and that's not necessarily the case. A lot of the first systems started to be introduced and started to gain publicity, and around the 1990s, we really saw some systems start to come around in this space. In 1999, one of the main systems that we see today in the green on brown space is the Weedit system, and they were founded in the Netherlands in 1999. In 2007, 2009, we started to see a lot of adoption in Australia. This is notable because a lot of times Australia will sort of lead what we see for agriculture here in the United States. They often face a lot of problems before we do, and so we can learn by paying attention to what they do and how they deal with issues in their production systems. In the late 2000s, 2015, 2020, we started to see more global adoption in this space. We started to see a lot of companies announce that they had research interests in this space. Mergers and acquisitions were taking place as companies were actively trying to invest themselves in this technology to make sure they could compete in this space in the future. Finally, I think it's worth noting, this year in 2021, John Deere released a product they call See & Spray Select, and this is a green on brown spraying system that they released for their sprayers from the factory. I think what makes that notable is just that it's from the factory. This is the first large OEM manufacturer that we've seen provide a targeted spraying system on their machines from the factory. In the past, these systems, have had a lot of different limitations to them, though. So they often required very stable booms and slow speeds. So we would often see these systems on a trailed type sprayer with, maybe ground engaging dolly wheels on the boom to ensure that we're placing that boom and the sensors on there, that we're placing them in a way that they have a really good opportunity to see that weed. And that we're going slow enough that we have a good opportunity to process the data that we're taking in and then turn on a nozzle and get product all the way down to that weed. These systems in the past were almost always green on brown technology. We haven't in the past seen much green on green space or green on green technology in this space. Width was often limited just due to power and cost. So we typically didn't see these on a 120-foot self-propelled sprayer boom for several reasons. The technology was very expensive. It's still expensive today, but it was even more so 10 years ago. And then power. A lot of times, these sensors that we're using, the controllers to actually compute and make decisions about what the data the sensors are bringing in and then actually fire a nozzle, these are all power-intensive operations that can require a lot of electricity. And oftentimes our machines were just physically limited by the amount of electricity that was available on board to actually function and operate these types of systems. So where we're at today. We see adoption today on both towed implements like what we just talked about, as well as on self-propelled sprayers. Those are becoming more of a common sight to see in this space. We see technologies using both optical and fluorescence-based technology. So on the left here, I have a picture from John Deere of their See & Spray Select system, which is using an optical camera-based system to view and identify weeds. Versus the Weedit system that's shown on the bottom, which is using a fluorescence light-based system to reflect light back and identify where there's green and then turn on nozzles to effectively cover that green area on the ground. We've seen width grow as well in this space. We're seeing, this is very capable today to put on 120-foot machines. We have better computing power. We have better boom control systems out there today to allow us to better position that boom to ensure that we're giving the sensor the best possible chance to identify the weed. And then finally, better computing power to help us, process those images faster and actively spray the weeds precisely and accurately. In the future, we're likely going to see, the green on green technology space continue to grow. And this will start to have an impact in row crop production here in the Midwest as well as across the world. The ability to identify, spray and map based on weed type or other properties that we might care about has been discussed by a lot of manufacturers. As we go around to trade shows and farm shows around the world, this is a common topic that we see is, companies demoing technology that they're working on and talking about the types of data that they're able to record and things that they can learn that eventually, hopefully, they'll be able to apply to production machines and production agriculture. We'll likely need to see continued improvements to boom control and operating speeds of these systems. So as this starts to go on, as customers in production agriculture, we're going to continue to demand better technology, and we're also going to want that technology to work at faster speeds. And so that's going to require continued improvements in boom height control systems to, again, make sure we're placing that sensor and those nozzles in a position where they can truly be successful, and operating speeds to further push productivity enhancements of these systems. So before we go on, I want to talk through a couple different operating modes of a lot of these systems. I think it's worth noting that these systems don't just operate in a targeted spraying mode all the time. Most of these have additional flexibility pieces to ensure that you can use them across a broad number of acres in various operations. So of course, these systems have a targeted mode, right, where we can identify a weed and spray just the weed. That's the critical piece of the technology that we're really after, and that's what we want to use, and that's where we're going to save the most money and really pay for these systems. A lot of manufacturers out there are advertising that they have the capability to do a targeted plus a light rate. So what this might mean is we're putting out a light rate across all the nozzles on the boom. So think a very, kind of low carrier volume, maybe a lower concentration of product that we're putting out across the entire width of the machine. This is really targeted at, hitting and controlling really small weeds that just emerge, weeds that maybe we will miss with the sensing capabilities on these machines, just because they're so small, or they might still be covered up by a piece of soil or a piece of residue that's in our field, and we won't be able to see them. So we're putting out that light rate, and then simultaneously we can still look and try to detect where there's large weeds in the field, and then we'll give those large weeds an extra dose of product. Where we know that light rate wouldn't be effective on those weeds, we can up the carrier rate, up the product, and really give those weeds a harder dose to ensure that we get good control of them. Finally, most of these technologies can all still be used in a broadcast mode. So if you don't have you can't spot spray for whatever reason, in a field or an environment, then you can default back to a broadcast application. Or if you're doing some sort of fertilizer type application, you still have that ability to go back and use the machine in that type of a scenario as well. Moving forward in the future, I think it's also worth thinking about how does autonomy and drone applications play into this space. So from an autonomy perspective, we still see a lot of companies exploring this space. The example I have here is what was the Raven Dot machine, and they've since renamed that, and that's been acquired now by C&H. So there's probably some name changes and such there, but the idea that this machine can still have a really nice width, right? Maybe 90, 120 feet. But maybe this machine goes a little bit slower. That could have some real implications to See and Spray technology. If we have an autonomous machine, maybe we're not as worried about pushing the speed boundaries of these systems, and we can let these autonomous machines slow down and really do a good job at trying to do a targeted spraying application. With that, think through the tending setups, right? How are you going to tend, an autonomous sprayer, and those types of things are all questions that we get asked and are really worth thinking about in this sort of environment. The next is drone applications. So we see this today. There's companies in the state of Iowa, companies across the country that are actively exploring using UAV and drone technology to apply pesticides or apply dry products to production agriculture fields. I think these make a ton of sense, for tight to reach spaces, right? Maybe wet areas of a field, small areas where it just doesn't make sense to get a large self-propelled sprayer into. And we're going to continue to see that type of application and adoption grow in these systems. But it's also worth thinking about what might this, UAV sprayer, drone sprayer be able to do if it was able to, just prescriptively apply product to certain areas, or even identify, where there's problematic areas of a field and then just go apply to those areas instead of, doing a broadcast application, which is still very typical what we see with, even drone UAV technology today. So a couple of considerations for adoption here. So these are very technology heavy and intensive products. So this is, we're adding a lot of sensors to a machine, a lot of wiring and wire harnesses, a lot of different controllers to a machine. That's worth noting and understanding, as you're starting to think about how this might fit into your operation, in the future. And again, we're not talking about these products, being adopted next year here in the Midwest. Before we truly have green on green, widespread adoption, we're probably talking 5 to 10 years is when I want you to think about, how these technologies and what to consider in that sort of time frame. These systems require individual nozzle control. That's sort of a given. If we're going to only turn on, one nozzle, two nozzles at a time to target a specific weed, we've got to have a way to do that. So we've talked about individual nozzle control in the past, and there's a lot of benefits that can come along with that technology as well. And that's sort of a pre-requirement to having targeted spraying technology is having a system to do individual nozzle control. I want folks to think about, how much spraying do you do in the daytime versus at nighttime, right? And how do the different systems, how are they able to handle that and address those types of different environments? Also think about kind of the twilight hours, right? These systems, most of them, like we talked about, are using optical, image sensing, or even the systems that use light. There can be challenges with, transition periods in the day, changes in cloud cover and lighting can affect that. So think through how you typically spray and how might these systems, how much you need to change or set these up depending on, the type of day that you're dealing with when you're spraying. Also, there's going to be other features that we want today, or we want with targeted spraying systems that just aren't on our machines today. A lot of these aren't even on our radar today. We're not thinking about these features on our machines today because we don't really have a need to. There's a lot of benefits to some of these that could benefit us today, but they're not on our radar, but they will be in the future as we start to look at how targeted spraying technologies might be a part of our operation, again in the 5 to 10 year type time frame. We're going to start to talk through how could this technology impact you and how might this impact and be a benefit to your operation, your clients, your customers. So we're going to need to adjust our herbicide plants. I think it's a given that we're hopefully going to save product with these, right? We'll use less pesticides. So in doing so, that should give us an opportunity to maybe use better products, right? Maybe we can put more modes of action in the tank. Have a more complete prescription that we can put on weeds to ensure that we're getting really good control when we do turn a nozzle on and target a specific weed. Most people realize that if we're only spraying a small percentage of the area in a field, we're going to save quite a bit of time due to less tending of the machine. We're not going to have to be filling as often because we're not going to be spraying as much product. So how are we going to use that extra time? We can certainly cover more acres in a day. And maybe that means we even spray a field multiple times or more times throughout the year than what we do today. And while that may seem somewhat counterproductive, I want you to think about the opportunity to really try to target a weed when it's most susceptible to the herbicide products that we're trying to use and put out there. So we all know that it's typically easier to kill a small, 2-inch tall water hemp than it is to kill that 6 or 8-inch tall water hemp. So by getting out there more often, we're going to be able to hopefully get better results, even with the herbicides we have available today, by targeting those smaller weeds. And that's one way we could potentially use the time savings that we'll get with this technology, to just really better our weed control in our agricultural operations. Maybe we can use this technology since we're not filling up as often, we're not spraying as much. Maybe we can apply higher rates of higher concentrations of the herbicide products and maybe higher carrier volumes to get better coverage. So we know that many weeds are susceptible to the rate of the product you put out, the concentration of that product, but also the general level of coverage you get. Certain products have to have really good coverage. So if we're not worried about how often we have to fill the tank, maybe we can put out a higher volume of product to ensure that we're getting good coverage. The ability to spray higher rates of a product or higher concentrations, has been demonstrated in other parts of the world and has had decent success in some areas. But it's worth noting that's going to take, label changes, right, to do that. The label is the law, and we have to legally follow that. And so this is an example of where, it's going to take some regulatory updates to really match and allow us to adapt to this new technology that's going to become available in the future. I want folks to think about and consider different types of owners of the machines and who owns this type of technology and utilizes it. So one example is co-ops and service providers, right? How might they own this technology and utilize it to provide value to their customers? The next is farmers and folks that maybe do a little bit of custom work on the side, right? How are they going to own this and pay for it and provide value to themselves and their customers? And then finally, you have just farmers that might want to own this, right? And how are they going to look at this system? How are they going to cost flow it through their operation and ensure that they can get a good return on investment for these? So I like to, this is similar to like what we see with variable rate technology in a lot of dry fertilizer equipment today, right? Where if you want a variable rate, oftentimes there's an upcharge for that type of technology. And so this is a great example where we might see that with these types of systems in the future. The cost of adoption is certainly can be high with these systems, right? Most of the time, I think, on like a self-propelled 120-foot boom, you're going to be looking at easily a six-figure, $100,000 plus type of upgrade option. Like we talked about, there's just a lot of technology, a lot of extra hardware that has to go into this, but also just a lot of time that these companies have invested in developing and ensuring that these products work and do a good job. That those costs have to be accounted for. So, there's different ways to look at this, right? So you could, as we've talked about, you can get a machine from the factory today that has this technology, built into it in a really integrated option that a lot of folks will want to have. That's one way to do it. Alternatively, you could also upgrade an older machine. And this is actually, as we've had experiences and talked with folks, throughout the country here that have utilized these systems, this is often an option that they like to do. So the idea of, you go find an older machine that has several thousand hours on it and, is starting to maybe be a little more prone to having problems, right? You might take it, you outfit it with a targeted spraying package on that machine. And then a lot of times that's all that machine will do is do targeted spraying. And the reason for that is it's kind of a cushy end of life, job for that machine, right? In targeted spraying, we're not pushing as much volume through the machine. We're not typically going as fast. All of those things come into play and really kind of make it a cushy job for a machine that has a few hours on it. And then you can save and have a newer machine maybe that, costs a little, you buy new from the factory. Maybe doesn't have this technology, but that remains a broadcast machine. That might do your high rate fertilizer. Some of those types of things that can just be really hard on this type of technology when you expose it to, chemicals and fertilizers and machines operating at a high rate of speed. So we can kind of protect that large investment in that sort of scenario by putting it on an older machine and really limiting it to only doing those targeted spraying acres. We briefly talked about payback before. There's different ways that folks are going to want to pay for these systems, right, and how they're going to look at the return on these. So, as a grower, right, we're gonna look a lot at herbicide savings, right? How much are we saving on products that we put out there? And that's going to be a key way that we pay for this. We talked about folks that are doing custom work. They might have an additional technology fee that they can put on top of their typical rate to do these types of, to have this type of technology available to their customers, who would then still receive some benefits of this by having to pay for less product to go out through that custom application. We've also heard the idea that this could be a kind of a sell a result or outcome-based type pricing, right? Where, I think this is many years down the road, probably with the idea that, someone's not necessarily just selling you a herbicide plan for the year, right? They might try to sell you, a 99.5% weed-free field. And, however they achieve that, sort of up to them. And this targeted spraying technology might be a tool in their toolbox that they use to achieve that outcome. And can help them, be competitive in that space and hopefully, make a profit on their business. The potential for cost savings is certainly high with these systems. So we know that herbicide prices are significant, and we don't typically see them, coming down in the near future. I've got kind of an example here. This is a kind of an Iowa Midwest example. And again, I want to reiterate, these technologies really don't apply here today, right? We really only have green on brown options available today. And so this scenario is a little bit based in the future, right? Think about 5 to 10 years from now, when maybe we have green on green technologies as kind of a mainstream option in, row crop production agriculture here in Iowa. So today, or 2021, the estimated cost of crop production, corn herbicides were about $40 an acre and soybean herbicides were about $50 an acre. So if we think about a 5,000 acre farmer, or someone is spraying 5,000 acres, let's say that's a 50-50 split between corn and soybeans. And let's just use a very conservative, average savings of 30% across, all their applications. Now, this isn't necessarily true, because on our pre's we may still need to broadcast residuals. We'll have to work in some of those pieces. But let's use a conservative number of 30% to start with. And if we can save 30% across those 5,000 acres for corn and soybeans, we could easily be talking $30,000 on corn and $36,000, $37,000 savings on soybeans just in saved herbicide costs. So the opportunity here is big, even though we know these numbers may not be quite right. Really using this to just illustrate that the opportunity is big. As we've had opportunities to be exposed to these systems over the last several years, it's not unrealistic. We see systems ranging in herbicide savings, in fields from 15 to 90% herbicide savings. The amount of savings really directly correlates to weed pressure, right? You can't go out to a really weedy field where there's weeds everywhere and expect that you're going to save 90% on the herbicide use, right? That's just not realistic. But if we have, some ground where we just have a few weeds, but we know they're really invasive weeds, potentially resistant weeds, we know we need to get out there and control them. The ability to go out and only spray the 10%, the 15% of that field where we have those weeds, can really demonstrate a huge savings in these environments. Now, that was with 30% savings, right? Let's, again, thinking 5 to 10 years in the future, what if these systems could save you 80% on your corn and soybean herbicide use, right? How would that impact your operations, and how would that, give you new flexibility and new opportunities within your production operations? Want to take a minute and step back, and really reiterate that, this isn't a silver bullet, right? This is a new tool in the toolbox, but we're still relying on herbicides as the way of controlling weeds. And so product efficacy still matters. In general, IPM, integrated pest management strategies, still apply, right? We still have to be making sure we have a good plan to control these weeds with multiple different, ways of doing that in our operation. Also, you won't see every weed. We cannot expect these systems to see 100% of the weeds that exist in our field. Today, I think most of us would argue from, just being in this space and, having boots on the ground, with a good broadcast application with the right nozzle on a machine, it's very realistic that we can get product on 100% of the weeds in the field. Now, notice I said get product, right? I think we don't typically get 100% control of all the weeds in the field, right? We have things like herbicide efficacy and, did we get good coverage and what were the environmental conditions, all play into, how many of those weeds actually do we get control of. But one thing we think about is if we can't see a weed, we can't spray a weed, right? And all of this comes into play. We might have weeds that are nested under a piece of residue, like what I'm showing in this picture here. Depending on how the machine comes and approaches that weed, there's a very realistic possibility that corn stalk there is going to shield the weed from that machine seeing it. And that if we can't see it, there's no way that we can activate a nozzle and effectively spray that weed. So we've got to think through, how do we deal with those types of situations, right? And how are we going to manage those in our operation with this type of technology in the future? We've also got to be able to evaluate and trust the system. So, this is going to be new technology to most folks when it starts to come around. And we know that in the agriculture space, we don't necessarily want to take a lot of risk, especially with things like this that can, be problematic for us for years to come. So one thing we found over the years is, using dyes in the tank to actually go out and validate that these machines are working. So couple, examples here. One is, you can see little dye specks on the weeds themselves. Sometimes that's easier than others to see those bits of dye on the weed. But you can also oftentimes see it on residue around the weed. And we've illustrated that with the UAV photo on the right, that you can actually see the blue haze around a lot of weeds out in that photo. And so being able to, do exercises like this and prove to yourself and prove to the customers that the technology is working and doing what it should, can be a really powerful way to go about and start to learn in this space. Over time, we've also learned, as you're just getting your feet wet in this space, it's a lot easier to do this with just water first, right? So think about even maybe, doing part of a field or a demo with customers and doing that with just water in the tank and, just water and dye. So that way it's really easy for you to walk out there and have those conversations with people without having to worry about all the safety issues that come with walking through a field that just had freshly applied herbicides, in it. This can also be a really cool way to evaluate different machine settings, maybe different nozzles that you want to use on the machine, and really understand, what are the different knobs that you can turn on these systems? What do those mean on the ground in terms of coverage, in terms of, good weed control, in terms of the overall amount that you're spraying, right? And evaluate, where do you want to operate this type of technology in your operation? There's various methods that have been used to try to evaluate this type of technology. We've been working on some of our own methods here at the university for the last several years to try to evaluate and really look at what does success mean in these operations, or how well is a system doing compared to a broadcast or compared to another system that's out there today. These are something that hopefully are going to start to be published over the next several years. As these systems start to become more mainstream, we know that folks are going to want to get their methodologies out there and published so that others can use them, and that also allows us to use the same sort of measuring stick to evaluate performance and success by. So that's a critical piece to understanding and comparing different systems or different setups, from one area of the country to another, or even one day to the next locally, is making sure that we're using the same measuring tools. Typically, I like to talk about looking at evaluation in kind of two different ways. So the first is using dye to truly evaluate how well did the system do at getting product on the weed, right? That's the first thing that we have to do, is we have to be able to sense the weed, activate a nozzle, and get product on that weed, right? And so that's kind of the first piece of it, right? Is do we get product on it? And what is that? How well do the machines perform in that sense? Finally, this is typically done, days later, maybe a week to 10 days later, is evaluating how well did the technology and the herbicide plan you put together, how well did that do at actually eliminating, live weeds out in the field? And so we call this, going back and evaluating the density of living weeds after the herbicide application, looking at, how many weeds are still out there and alive today. And that's another piece of this that's important to evaluate and really truly understand the full agronomic story that can come with these types of technologies. Today, we often see performance of these systems, again, mostly talking about, green on brown systems, right? Because that's pretty much all that's commercially available today that we've been able to see in different parts of the country. It's realistic that we see documented performance of, hitting 95 to 99% of the weeds, right? And again, we're talking about getting product on those weeds. So, the ability for the machine to sense and apply product to, 99+% of the weeds is a realistic expectation when the machines are properly set up. That setup piece is critical, right? There is opportunity that we can not get it right on a day. And, what happens if we have a setting wrong, or we use the wrong nozzle, or there was, too much wind on a day, right? That can all impact our ability to get good coverage of the product on the weed. We also see product savings, again, directly correlate to the weed pressure in the field, but it's not unrealistic to see 15 to 90+% product savings in different scenarios and different environments. And, those can have a huge impact to cost and to logistics and really to the bottom line of many operations. Again, I want to hit on performance is limited by a lot of things, right? So machine settings, often these are called different sensitivities in the machine, right? And we can turn those knobs and adjust those. But performance is also going to be impacted by the herbicides that you choose, the rates that you're applying those herbicides at, the ambient lighting around on the day, the size of the weed you're trying to hit, the type of nozzles that you have on the machine, right? All of those things are going to come into play and will have a role in determining how successful these technologies are moving forward. So I want to talk about productivity. This is a piece of it. We've mentioned it a couple times, and I think it's worth digging into just a little bit here. So it's very common common knowledge. A typical self-propelled sprayer, often spends, we kind of use the rule of thirds, often spends about a third of its time spraying, a third of its time tending, and a third of its time in transport mode, right? Moving from field to field. But we only get paid for the spraying portion, right? Typically on a self-propelled sprayer, whether it be a co-op machine, right, where we're getting paid, a certain dollar for every acre that we cover with that machine, or a grower where we're trying to get over, a certain number of acres per day, right? That's the piece of that equation that really matters, is the percent spent spraying. So targeted spraying systems, have a benefit here, right? We're going to spend less time tending. We're not going to be pushing near as much product through these machines. And so we'll spend less time in that tending category. So maybe we can move some time from the tending bucket to the spraying bucket and allow us to be more productive with a given machine. It's also worth noting if we're covering more acres per day, though, there's a chance that we could increase our transport time, right? If we're covering more acres, that means we might hit, one or two extra fields a day, and we're going to have to drive to those fields. And so we might also increase our transport time a little bit, which isn't necessarily a good thing in these. Cons of these systems are certainly there as well. So, especially here early on, right, we may not be able to spray at the typical speeds we typically operate at today. So, we might only be able to spray up to 12, maybe 15 miles an hour, where it's not unrealistic today that we see self-propelled sprayers operating at, 18, 20 miles an hour in a field. And again, we've talked about it, but we may need to spray or want to spray more often, right, to, again, really target those weeds when they're in a good susceptible state. And so that may also, play a factor into just how productive and how we utilize, every hour of a machine with this type of technology. I want you to think about logistics planning, right? How does this play into the logistics of your operation, right? One of the biggest hurdles that many folks have to overcome when they start using this is you don't know how many acres you're going to spray, right? You don't know what percentage of that 100-acre field you're going to spray, right? Are you going to spray 10% or 10 acres? Are you going to spray 50% or 50 acres of that 100-acre field? So we have to, get good at estimating how much product we're going to need, and we might overestimate or underestimate how much product we need to load into the machine. How's your chemical suppliers? How is yourself going to go about, doing your planning for the year of your chemical supply, right? If we don't know exactly how many acres we're going to spray on, we may not accurately know how many gallons of a certain product we need to order and have on hand, right? So that's going to be a piece that we're going to have to start to figure out and deal with over time, is just the overall supply chain of pesticides within the agriculture industry. As we talked about, not only, timing's critical, right, to getting good control on a weed, and it's going to continue to be more critical in the future. Also, as we start to think about green on green technologies, I want you to think about how does the crop canopy start to play into that, right? If, we are able in 5 to 10 years to go out and sense weeds within the crop canopy of the desired crop we're growing, how does that canopy affect our ability to maybe see weeds that are down in the row or, underneath that soybean or that corn leaf, right? And how does that impact when we might want to target spraying that field, depending on what the crop canopy looks like? Nozzles are also likely going to be different in the future. So today we often rely on, really wide angle broadcast nozzles that have overlapping edges and, maybe put out less at the edges, but we know we're going to get overlap from the neighboring nozzle. Those are very common nozzles that we use today. These likely won't be the nozzles we want to use in the future, right? If we're only turning on a couple nozzles to spray a weed, we may want to concentrate that product right in that area. We may not want to have a tapered nozzle where we're putting out, varying amounts at the edges versus in the center. We may want to have more of an even or use like a banding nozzle, right, where we're getting a really defined concentrated area of product, right where we believe that weed is at. Today it's not unrealistic. We have like 100, 110, 120 degree nozzles. And just to illustrate that, I've got this chart here that shows, even at like a 36-inch boom height, right, that nozzle might easily be covering 80 plus inches on the ground, right, that we're spreading that nozzle out over 80 some inches. And you start to think about that necessarily doesn't make sense when we talk about, the ability to really target and control an individual weed. And so that's what will drive some considerations around what types of nozzles we want to use with this technology in the future. Again, it's worth noting here, a lot of times we're restricted on the nozzles we use by the label. Again, the label is the law, and so this is another area where we might need to see changes in the product labels, to really support and allow us to effectively adapt to this technology in the future. We've talked about it a little bit already, but boom height control, we'll argue, is very critical today, right? We need good boom height control to ensure we're getting good coverage and good efficacy of the products we put out there. And it's going to be even more critical tomorrow. So as we start to see these systems continue to become more common, these systems start to get more accurate, they start to travel faster through the fields, having good and more accurate boom height control is going to be even more critical than what we see it today. Again, this really comes back to ensuring that we have a really steady platform or boom to sense those weeds and apply product from, right? If our boom's moving all over the place, that's going to make it really hard for the sensors to sense the desired weeds out there, and for the nozzles to really effectively get product on those weeds. So again, I've got this chart here that illustrates, how nozzle coverage depends on boom height, right? And I just want to use that to drive that point home, that depending on where we put that boom, right, that can have a drastic impact to where we put the product on the ground. And that's really important to consider as we start to talk about targeting specific areas on the ground moving forward. Also, beyond targeted spraying technology, I just think we're going to generally continue to see a drive towards lower boom heights. So there's a lot of environmental reasons why we like lower boom heights. They are less prone to drift, right? We get the product closer to the ground. There's less time to evaporate, lose particles between when they discharge the nozzle and when they get down to the weed. There's a lot of benefits to that, and so I think we'll continue to see boom heights go lower anyway. That'll also drive some changes to how we see nozzles placed on the boom. As we go lower with boom heights, we may need to see our nozzle spacings come in a little tighter to, again, just making sure that we're getting good coverage and good control of the weeds on the ground. One of the technologies that I think is likely going to be very prominent on these systems in the future is recirculating boom technology. So again, this is a great example of one of those features of a machine that's kind of somewhat available today that we don't think a lot about, but it will likely be almost standard or at least very common on targeted spraying machines in the future. So what these systems do is, typically on a spray boom today, right, we might feed product through a metal tube from the center, and then the nozzles are mounted on that tube, and then we spray product from there. Those systems are typically deadheaded at the ends, right? And so those deadheads at the ends of our spray boom can allow opportunity for product to become stagnant and build up at the ends of those. And we fight that today, right? Those can be our sources of contamination. We might get plugged nozzles in those areas of our boom. And so these are often issues we fight today, but this will be more problematic as we start to talk about targeted spraying machines where we're not pushing out the volume that we typically do. Or we might go for periods of time where we're not spraying anything out of a certain area of a boom, and having stagnant product out there with the potential for things to settle out, is not ideal. And so recirculating booms eliminate those deadheads and constantly push product out to the boom, but then allow product to leave the end of the boom and recirculate back to the solution tank, so that we keep everything mixed and in solution, which has a lot of implications to product efficacy and just ensuring that we can maintain a nice, clean machine with the products we're applying. So it'll have some big implications for targeted spraying for that. There's also some other features of this, though, that could be valuable and beneficial to us, just in general, though. So the ability to reclaim product. So a lot of these systems can actually allow you to push all the remaining product in your boom and push that back to the tank. Once it's in the tank, it might be easier to capture that product in a container and properly dispose of it. When we go to prime our boom, we get instant boom priming with these systems. So because they're constantly circulating, we don't have to wait to push all the old product or all the water out of the boom before we get the stuff that we mixed up in the tank. It's always circulating, and so we instantly have full rate product back at every tip of the boom. And finally, most systems today, we don't worry a whole lot about pressure drop across the boom. Most systems have gotten pretty good about managing that. But this system can also help eliminate any remaining pressure drop we might have in our systems, and just ensuring that the nozzle in the middle of the machine is operating at the same pressure as that nozzle out at 60 feet away at your boom tip. So a couple of wrap-up conclusions here. So we see large opportunities, exist to reduce herbicide volumes with these systems, while also increasing our flexibility with timing and with our herbicide plants. And that's a key benefit to a lot of these systems. These systems are complex. We're going to acknowledge that up front, and we know that this technology may not be for everyone because of how complex it is. And these machines, are likely going to take a different level of operation and skill just to really ensure that they're operated to the best possible degree. Testing and evaluation is key to that, right? To ensuring that we get these complex systems set up and operating right. Good ways of evaluating their performance is going to be a really important thing moving forward in the future. We know this technology won't hit 100% of the weeds. We cannot expect this technology to perform any better than a broadcast herbicide application would today. And so we want to think through in 5 to 10 years, right? What level of effectiveness are you going to be willing to accept, right? And how do you manage those few weeds that you might not hit in any given application? How does that become part of your production operation? And again, just want to stress that, we're still using herbicides with these systems, right? So they're truly just another tool in our toolbox. And we still have to pay attention and use, good pest management strategies to ensure that we're getting good control of weeds and limiting, resistance buildup. So again, we didn't have a lot of data here to present today, but I really wanted this discussion to be focused on thinking about how does this impact you, your clients, your customers, your operation, 5 to 10 years in the future when this technology might become mainstream, and what does this look like and how might you want to utilize this within your operation, to just gain flexibility and you gain, good weed control. So thank you for having me talk with you today. My contact information is here. Feel free to reach out if you have any questions. And thanks for watching this episode of Crops TV.